Hey everyone, welcome back. So, the upcoming session is about sync versus async in Python. Tools, benchmarks, and ASGI, WSGI, everything will be explained in this talk. The talk will be delivered by Arun Suresh Kumar. He's right over here. So, please welcome Arun to get started. Please give him a background of applause.
Thank you, Koti. Thank you. Am I audible? Okay. So, uh, good afternoon to all. My talk is about sync versus async in Python, and I will explain about ASGI and WSGI. Uh, Myself, Arun. I am from Kerala, India. Currently working as the entrepreneur in residence for UST. I have experience of more than 10 years in Python. I contribute and collaborate with GraphQL ecosystem and strengthening that ecosystem in Python. Away from Python, I also do bug bounty programs. I also participate in bug bounty programs and identifying and resolving and reporting the vulnerabilities to companies. That's all about me. And I'm also part of AWASP Kerala chapter, and I'm part of the board of that AWASP Kerala, uh, and contributing to the web security awareness and practices for the chapter. And this talk will have the topics synchronous and asynchronous programming, server gateway interfaces, HTTP servers, migrating from the sync to async from our insights, and we will help you with a benchmark designing process that we use for deploying the production application. Okay, we start with synchronous and asynchronous programming. You can see the representation of synchronous and asynchronous programming on the screen. So if you look at the screen, like there is something called sync and there is something called async. And if you look at the difference between sync and async, we can say something like synchronous program, it has some orders. It only execute one task at a time. And if you look at the asynchronous program, there is something called we can handle multiple tasks. And on a real-time example, we can relate this something with somebody who is in the line for a coffee can be articulate or related to the synchronous programming. If you want to relate something with asynchronous programming, if we are browsing a website, we can either browse the website or upload something at simultaneously, right? So the asynchronous programming is related to that. So it's all about it's a nutshell about it's a glimpse about synchronous and asynchronous programming. So we'll talk about Python and its asynchronous support. So if you look at the evolution of Python and its async support, even from the version of 1.5.2, the async core has been introduced. Looking at 2.2, the generator yields has been introduced. The multiprocessing has been introduced. Yield from G event, async IO, and it's a major release that it has been supported by the native support has been introduced from 3.4 of Python version, async IO, and the keywords like async and await has been introduced in 3.5. So this is the evolution of Python in terms of async support, and it's more about a concern how to choose between synchronous and asynchronous programming methodologies while creating an application. So in my perspective, if you want to do something simultaneously, I prefer to move with asynchronous programming methodologies. And if you need to create some reactive systems, the better one will be asynchronous. And if you can check out the difficulties of handling that, if you are creating a POC, then the best way is to do a synchronous thing. And while looking at the debugging, the practicality of debugging, asynchronous programming is a bit hard compared to the synchronous programming. Synchronous programming can be debugged in a simpler level. So choosing between asynchronous and synchronous is completely based on the need and the necessity of what we are building. So, and here is sample code, synchronous versus asynchronous sample code. You can see the same functionalities has been written in the synchronous form as well as an asynchronous form. You can see two functions are defined. In synchronous, we define the hello and main function. And in the same async, we defined hello and main function, but you can see the difference, right? From 3.5, there is something called async and sync keyword has been introduced, and we need to prefix async to a function if we are defining an asynchronous function, and if you are calling some asynchronous function, something called coroutines, so we need to use await function. You can see the main function is calling the synchronous and asynchronous function. And if you look at the asynchronous, async.py, we are using asyncio.run to call the main function because it's defined as an asynchronous coroutine. And we can also use multiple event loops. Now it's using the default event loops. There are something called uvloop and many other event loops are available. You can use based on your requirement. So this is a basic example how we can write asynchronous and asynchronous programming. So as I discussed about the event loop is an important key thing that we need to have to be aware while creating an asynchronous programming. So we have a main thread and an event loop and something related to the OS. So every time some asynchronous programming is executed, it will be queued, and the event loop will monitor that task. If something, they will work something that required for the CPU. If something is happening, the task that could require some I/O operation, for example, accessing database or something else, it will be moved to the OS to a queue, different queue handling the I/O task, and the OS will notify with an interrupt to the event loops that this I/O operation has already been completed and it has been getting into the event loop. And this is how the event loop works, and this is how the asynchronous programming handles multiple tasks simultaneously. Once the CPU utilization is over, the CPU work is over, and if something is taken care of by an I/O operation, it will be moved to a different thing. So this is the working process of event loop. And we need to discuss more about the server gateway interfaces. This is how we are kickstarting the core of this presentation. So you can see a web application architecture which has been created in Python. There is something called browser, a tool, something like which can create HTTP request and which can render the HTML. And we are using the Nginx for the demo purpose. So Nginx is acting as a proxy server here. It can serve static files and also acting as a proxy for the Uvicorn. And here you can see that Uvicorn is connected to a Uvicorn worker, and that is connected to a fast API framework. It's an application framework. So basically, this is the web application architecture, and we will explain more about how it will be enhanced. So, okay. Okay, and now we need to discuss more about understanding WSGI. WSGI means like Web Server Gateway Interface. Here you can see a WSGI.py file. In that, there is something called there is a definition of a function called app. It's having two parameters, environ and the start response. For example, environ is a dictionary with the information that the server is getting from the user, the request. It can also hold cookies, headers, anything and everything related to the request from the client side can be accessed with the help of that dictionary. And start response is a function which initiating the sending response to the client. This is the basic bare-bone function which is defined in the WSGI application. And this functionality is used by different frameworks. On top of it, they will create middlewares, they will create other functionalities. But this is the basic code snippet that we can use to create a WSGI application. And the downside of creating a WSGI application, like it can only handle a single request, a single request and a response at a time. So it's a synchronous way of handling web application, synchronous way of creating web application. We need to use WSGI. So it cannot support WebSocket, it cannot support long polling HTTP connections, and synchronous can be related to the blocking. So These synchronous web application will have the blocking codes. So we will get more details about what is blocking, what is asynchronous code in the next slides. So now we need to understand what is ASGI. ASGI is like asynchronous server gateway interface. This is how we can define the asynchronous server interface. The scope, receive and send are the arguments. Scope is something related to environ. It can hold the information from the client side. Send is an asynchronous callable application that help retain the response. And there is something called receive as well. Now the main difference between this is like they can interleave invocation from the multiple connections. That means they can handle multiple connections simultaneously rather than a synchronous way. So it is non-blocking. And these are some of the frameworks that we have which are supporting WSGI and ASGI. If you look at Django is supporting WSGI and ASGI. FastTP is supporting ASGI. Flask is supporting WSGI. Tornado is there supporting ASGI. Sanic is supporting ASGI. Falcon will support both WSGI and ASGI. These are the few frameworks, and there are more and more popular frameworks, but I just want to take a couple of things for the example or sample. And the quick from while getting to deal with WSGI and ASGI, so many people will ask which one is better, and the answer for this based on the use cases that you are planning to solve. If you are creating an application which has more and more IO operations, I recommend, and from my insights, and I recommend ASGI will be the right option for that, because there is something called event loop, and we can handle multiple connections at the same time if you are using ASGI. And you can see a picture, right? A presentation like a picture. The GIL has been released. For example, if somebody is starting a request, and if that need to be query something, we can, using the async way, we can release that, and which will increase the number of concurrent connections that the web application can handle. So as per my understanding, as per my insights, workers like Uvicorn can handle multiple hundreds of coroutines in a single worker, which will increase the stability of the web application which we are creating on ASGI, as well as we can reduce the cost related to the servers, which will be better one. And as per my recommendation, ASGI will be one of the best thing, but the use case matter. So, and we need to take care of HTTP servers then. And I'm showcasing 3 HTTP servers as an example here. There is something called Uvicorn, and Hypercorn, which we can use for, which we can use as a process manager or a worker for the frameworks like Django, FastAP, or Falcon. So before getting more about that, we need to think about the thread pools for WSGI application. You can see the web server, which can be related to Uvicorn, which can be related to Uvicorn. So the workers are the process. There is a settings we can set the number of workers which need to be spin. The workers can be related to the process, and threads can be, a worker can have multiple threads. This is how WSGI is handling multiple connections. And now this is completely impacting, or this needs more and more threads and more process to handle multiple connections, right? If you're looking at the ASCII version of that, I will show an example here. You can see the 2 versions. One is WSGI version and one is the ASCII version. You can see that in WSGI version, Uvicorn, we are using Uvicorn here, and there are multiple workers, and these workers are using multiple threads to handle multiple connections. If we are having 100 users, they are using multiple threads, which directly increases the number of connections, but it will be CPU sensitive. It will be getting more cost on the server handling. We have to scale horizontally as well as vertical for handling the WSGI application, for handling more and more requests, more and more users. While you are looking at ASGI, you can see that a Uvicorn worker handling the multiple connections using coroutines are simply threaded. You can see that as well, right? So the ASGI can handle multiple multiple connection in a single threaded, as a single threaded application. So we don't want to scale. We can reduce the server cost in some point, like because if we are increasing the threads, that means we need to have more and more cores because of CPU. So the best practice that we as a company, we as a team that we are using, that ASG is our recommendation in terms of building the application which scales, which handles more and more requests, having more and more IO operations. And the use case matter here as well. And now our experience and how we migrate from sync to async. This is from our experience. We handle multiple applications. We have multiple teams across the company. So we did a massive work in handling, in migrating sync to async. And okay, these are the few things that we take care of while handling the migrations. We need to make the whole code should be non-blocking. We have to make sure that our code are completely migrated to async in terms of we don't have any blocking codes there. And if you have any running blocking codes, you have to use separate thread, and which will impact the scaling because we need to increase the core and CPU as that. So you need to use task group for calling multiple functions simultaneously. Task group can handle or call. Task group can handle and call multiple. Okay. Okay. Task group can be used for call multiple functions simultaneously. And one quick hack is around the library called ASGI. If you might be using multiple synchronous libraries as well, right? We don't because the methodology of asynchronous programming has been introduced in recent years, so we don't have that kind of resources to migrate entire synchronous library to the asynchronous version. So there is a hack. There's a quick thing we can use. We can use ASGI ref, that sync to async functionality, to create or to migrate that function into the asynchronous version. They are using some thread pool executors for that. You can use that as well. Okay, and this is the migrated architecture that we did for our project and applications. You can see that the first version is WSGI version and the second version is ASGI version. And in WSGI version, we are using Flask or Falcon, and our code will be synchronous, and the libraries are synchronous, and ORM or ODM are synchronous. While we migrated the Uvicorn to the Uvicorn worker, and we completely migrated the framework to Fast API or Falcon ASGI, because Falcon support both WSGI and ASGI. We can use either one, the Fast API or ASGI, Falcon ASGI. Then we migrate the entire code. We prefer mostly to support native asynchronous support than using the synchronous to asynchronous functionality from ASGI, because it will impact. I will show in the later slides. So we can migrate the third-party application which is not directly supporting the synchronous using ASGI, and we can use libraries which support asynchronous functionalities as well. So this is how we migrate the applications. We migrate the synchronous application to the asynchronous way of approach. And the next thing is like designing a benchmark. The way of designing a benchmark is super critical for handling products or applications which handles multiple users. So we will help you with from our insights. From my insights, I will help you with how to design a benchmarking mechanism for your application. So you should be aware of a few things, because in the modern technology, in the modern world, we are using containerization, Dockers to deploy the application. So you should be aware of fake CPUs and the OS level virtualization. And we use Docker for the virtualization, and we call something called containers over there. And we use Docker for specifying the CPU shares and the containers in terms of memory, the CPU limit, and in real-life production scenarios, containers might run off the memory or CPU and shut down. We have certain instances when we are hitting more and more users. Sometimes the memory has been shooting out or the CPU has been shooting out. So we had to be careful about benchmarking in a bare metal versus a Docker container system. So it's something different. So we have to be very careful about benchmarking on those two environments. Here you can see the performance benchmarking. So we created an ASGI versus WSGI application here. We use Falcon for this because Falcon support for both. And for the example, and we took Falcon as a framework for that. If you can see that the two code has the same routes. We added two routes, ping as well as a different route to do some task. Here you can see that the asynchronous version, we are using asyncIO.sleep. You can see that this is a non-blocking code. You can see that in the left side, you can see that we are using asynchronous.sleep is one of the tasks. Some task is there. So in the WSGI module, we are using sleep time.sleep. Now you can see that one is a blocking code and other one is a non-blocking code. You can see the difference, right? So it's an ideal case for doing the testing over here. It's an ideal case. And we are using, okay, so you have an idea about how we created the ASGI.py file and a WSGI.py file, what is a blocking code and what is a non-blocking code. And we are using Locus for that. There are many other tools, but we are using Locus for that, for benchmarking the loads and how the real users will get impacted while more and more users are accessing simultaneously. And this is the way we can create a Locus file. Locus file we have to inherit the fast HTTP user, the class, which can have two tasks, which we are saying that the Docker, this Locus file will call ping. This Locus file will call the home page or something like in slash. So we can have the priority as well, like you can see the task of 3 tasks. Okay, this is how we create the Locus file. You can use the Locus or any other tool. There's something called Hey from the Apache or some tools are there, but we are using Locus for the demo. So we did a testing for the same code. I will show. For this same application, we run the test, and you can see the result. I think we will check for the first one. We will check for the WSGI, the synchronous one. It can only handle up to 100 users, and the request per RPS will be around 1.6, and it can only handle around 100 users. We done that test, and if you look at the ASCII version, you can see that it can handle 1,000 users, and 1,333.5 is the RPS, the request. And it's an ideal case for the sleep, but if you're having more and more operations in terms of IO operations, this test can be useful. And from our understanding, once we migrated into the async version, we are able to handle multiple requests across the globe. So this is one of the tests that we did for the demo purpose. And you can feel that there are unexpected performance dips. For example, the unexpected dips in the load test can be, you can check for the blocking code. If there are some synchronous code is already in the code, there you can expect some unexpected dip. For example, we create an application in synchronous way, but sometimes some codes are in synchronous way and some codes are in asynchronous way. The dip can be expected if we have some synchronous code, and if you have any network bandwidth limit, it can be shown some dips. And if you are using sync to asynchronous in too much, like if you are creating too much thread pool, it will also create some unexpected dips in the load testing. And as you know, all libraries which are existing as are not purely async. They are also using some underlying technologies like synchronous to asynchronous. So that can also be a reason for the unexpected dip. You can also use PyInstrument, cProfile, and PySpy for the profiling. And here's a case study done by Magic Stack. As I mentioned, there are many ORMs. So here is the ORM. The Async PG. Async PG is completely rewritten in the native asynchronous format. So in any other language or any other way of method, Async PG can handle multiple more requests than any other library. So if you are able to use native async library, which will increase the performance as well. So as of now, even for the last, even the async has been natively supported by the Python. The libraries are not yet migrated, and we are using MongoDB for many purposes, and we are creating our own open source contributions to create a native async support MongoDB ORM for Python. So you should be very careful about the libraries that you are using. Some of them are not really async with the help of default OS support. So here's my team. We presented different talks across different PyCons. We participated in EuroPython, PyCon Thailand, PyCon India, PyCascades, and PyConf. So you can scan the QR. You will get access to our talks. You will get access to our contributions. You can also contact our team or myself so that we can collaborate further on how we can increase asynchronous support in Python. Okay, then any questions? Thank you so much.
Any questions to Arun? So the mic is at the back. So feel. Yeah.
So quick question, when you were doing the synchronous test to compare, did you do any optimizations on the thread pools? Like how big were they, or what was the concurrency that you're running on those?
Okay, I will give an example like how we plan to migrate from synchronous to asynchronous version. So we deployed some of the production application in Kubernetes, which is having the synchronous code, and we wrote something for the test, for the health check as well. So while few users are hitting a couple of the endpoints which are IO blocking, our ping got failed because the entire thing is sync. And our Kubernetes pods are getting the crash loops each time. So that is how we migrated from sync to async. So we created a lot test for that as well. Before migrating the async version, we created a lot test for that. If they can only handle up to 10 to 20 users maximum, we can increase the number of threads. That can increase the number of users simultaneously. But the problem here is that the cloud cost will also be increased because if we are increasing the threads.
Okay, good, thank you.
Hi, so you had mentioned having some memory issues when running in Docker, or just at least encountering memory instances. I was wondering if you could expand on that at all when running, particularly ASGI, running out of resources as it relates to potentially Uvicorn.
Yes, good question. As I discussed earlier, we deployed a couple of Kubernetes applications, right? Our servers are getting down, but they are in the synchronous way of programming. Our servers are getting down. They are not responding to the users, but we don't have to see any memory hike or a CPU utilization in the synchronous programming because the thread is completely blocked for the IO operations and the users are not able to get the response, right? So while migrating the asynchronous version, we are getting the memory hike as well as the CPU hike, because the number of requests, while increasing the number of requests, that means the memory utilization is also being utilized. So while migrating from synchronous to asynchronous programming, we are we are getting the memory hike as well. Memory is being utilized more and more. So that is how we are using the load balancers for that. But while migrating the asynchronous version, we have to take care of the memory as well. We need to use some load balancing. We need to increase pods or something like that. But for sure, in synchronous, we are not expecting any memory hike, but users are not getting any result. But in asynchronous, users are getting the result, but memory is getting high. Thank you.
Hi. If I wanted to design an interface that's like ChatGPT, which is generating text back over time, would you use ASGI? Or on that, would you use something like WebSockets, or would you use like HTTP streaming? Would that be suitable?
I believe we need to use WebSocket communication over there, because we, as I mentioned, I closely work on the graphical ecosystem. So we use WebSocket communication for long polling thing. I believe HTTP 2 is also supporting in a different way. The version 2 is also supporting, without the WebSocket connection, we can pass information as a chunks from the server. So maybe ChatGPT might be using that kind of a version, HTTP 2 version, to pass the chunks of information, or else they are using some WebSocket or communication like that.
If you were going to implement that with Python, would that be ASGI?
We created, using the ASGI framework, Fast API, we created the WebSocket communication. So we are able to do that communication. We can create HTTP long polling communications or something like in ASGI, but in WSGI it won't be supported. You can create WebSocket or a long time communication, the ASGI version. I think it can solve some extent.
Okay. So thank you. Thank you so much, everyone. Thank you, Arun, for the wonderful talk.
Thank you so much. Thank you. Thank you.